What's going on, everybody? Welcome back to Deep Coding. In this session, we're going to talk about online stock span. You're given a class stock spanner and you're asked to design an algorithm to collect the daily prices and find the span of the stock. The span is defined such that if you start from today and go backward, what is the maximum number of consecutive days, again, consecutive days for which the stock price was less than or equal to today's price? Um, so we're going to complete this next function here. Let's take a look at this example. 100, 80, 60, 70, and so on. As the new values are coming, I need to take a look at the current value and look at the backward. If the elements before this element is less than or equal and is consecutive to this element, I just count it. Otherwise, I ignore it. Let's say I start from here, 100. There is no element less than or equal to 100 before it. That's just the starting. So I just put 1. Same thing for 80. When I look back, there is no element less than or equal to 80 when I'm looking back. The last one was 100, so I just put 1. That's just 1 day. 60, same thing. But when I get to 70, if I look back, I can take in 60, but I cannot take in 80 anymore. So if I look back from 70, I just see two elements or two numbers, two consecutive days that has the value equal or less than 70. But again, when I look at 60, look at the consecutive day before it, the first one would be 70. So it's impossible to have more than 1 day that it has less than or equal value to 60, as you can see one here. But when I look at 75, if I look back, 60 is less than that, 70 is less than that, 60 again is less than that. So we have four elements that are less than or equal to 75. But if you paid attention here, from 70 to 60, I already count these two here. But when I get to 75, if I want to go back and read them again, I'm just, overkill. It's just I'm doing it again and again. It's just redundant. So what is the best idea? How can I keep track of the previous values that I have counted before to prevent me from counting them again and again? The solution is monotonic stack. Let's take a look at monotonic stack and see how it works. Monotonic stack is a way to save values into a stack that are increasing or decreasing. In this problem, it's better to save the values decreasing, which means as the new value coming in, it should be less than or equal to the top of the stack. If we continue adding the elements following this rule, all the values in my stack are always sorted. Let's see how we can use it to solve this problem. I have my stack here. So when I start, I just push 100 into it. There is no other value. That's just the initialization. So I pushed 100 into it. And then when I looked at the second element coming, 80, 80 is less than 100. So I can just push it in. I don't have to do anything about it. Same thing for 60. When 60 is coming in, I just push it in. But when 70 wants to come in, the fourth element, 70, I look at top of my stack. But this time 60 is less than 70. So I cannot just simply put 70 here because it would break the rule, which is monotonic stack, decreasing rule that we defined at the beginning, goes down and then goes up. Instead of just pushing that element into my stack, it's better to pop the element on top of the stack until I find the first element in a stack that is greater than the element that I'm pushing in. So in this case, 70, 60 is less than that, so I just push it, pop it out. Next element, top of the stack is 80. Do I need to pop it? No, because 80 is greater than 70, so I just push 70 down into it. Next one is 60. When 60 wants to come in, top of the stack is less than 60, just push it in. But when it comes to 75, the next element 75, same as what we talk here, 60 is less than 70, so I just pop it. 70 is less than 75, so I just pop it. So top of my stack would be 80. Now it's a good time to push my 75 into it. So that's the monotonic stack as we talk. But here is better to save another element into my stack. When I'm saving each of the elements, it's better to save it in a pair of value and count. Count the number of elements that are less than or equal to this element if I go backward. So at the beginning 100, the count would be 1. Same when I go to 80, the count would be 1. For 60, same thing, 1. But when you look at 70, 70, 70 itself and 60 before are two elements that are consecutive and less than equal to 70. So instead of doing that, I just add 2 here. And as I'm moving on, 60 would be 1, and so on and so forth. Let's implement it to get a better idea of this monotonic stack. At the end, the summation of the elements that are popping out would be the answer of these elements. Let's start. So at the beginning, for each of the elements, I just need to put 1 because all the time, whatever value you have is less than or equal to the value you're inserting. So it would be part of the monotonic stack or part of the span. And then while the stack is not empty, I need to make it false. The stack, why the stack is not empty, and stack the top, that sec, that first is less than stack that, not the price actually. If that's the case, I need to say answer plus equal the stack the top dot second. Actually, I forgot something. Stack dot pop. I take it out. I forgot to define this stack. I need to define it as a pair of int and int. The first value in my pair is the actual price. The second value is count. Let's get it SDK. Now it's making more sense. After, so each time as far as I can go, that the first element, that the top of the stack first element, which is the actual price, is less than the price, I just move back. Actually, because it's a less than equal, I can do this. I just take the answer, I just take the count of that specific element on top of the stack and add it to my ans and just pop it out. I already keep track of the count. And when it's done, I just need to push this element, stack dot push this element, which is price, and the answer, which is the count. I've already taken care of that. And then I just return the answer. Let's run it together to see how it works. Yes, for the first element, 112146 and accepted. Let's run it and see how it goes. Okay, accepted. Perfect. Thank you so much for taking the time to watching this video. If you like it, click on like and don't forget to subscribe to be updated. Thank you.